So here we have another example of a composite function. It's cosine squared x. Very important here with that cosine squared x is that you realize that that is the quantity cosine x raised to the second power. Cosine x raised to the second power. F of x equals cosine squared x is equal to cosine x raised to the second power. Remember, we use that little shorthand notation on our trig functions because it's quicker to write down, but keep in mind and remember what that means. So now as we look at this, the inner function now is clear. It's the stuff inside the grouping symbols. It's the cosine. The outer function is the squaring operation. So u is cosine x, and then when we replace cosine x with u, we get f is equal to u squared. And so we set it up, and now we go ahead and we use our chain rule. So this time I'm not going to write down quite as much detail. So when I come to the outer function here, I'm just going to go ahead and do its derivative. Derivative of u squared is just 2u. Derivative of u squared is just 2u. And then times the derivative of the inside function here, cosine x. Derivative of cosine is negative sine. So f prime is 2u times negative sine x. And then we just simplify, clean that up, replace the u here with what it's equal to, which is cosine x. So putting all that together, we would have negative 2. U is cosine x times sine x. It turns out the derivative of cosine squared is negative 2 cosine x sine x. Negative 2 cosine x sine x. Okay, let's shift gears to another example here. This one also involves a trig function. It also involves a trig function being raised to a power. We have f of x equals tangent to the fourth of x. Remember, again, that is the quantity tangent x to the fourth. So once again, we want to recognize the inner and outer functions. And I'd suggest you pause the video and maybe write down what you think the inner and outer function is. Maybe even go ahead and see if you can carry through the derivative process. Okay, so hopefully you took a moment to try to work this out on your own. Let's work through this now. So the inner function is, again, our tangent function. The outer function is our u to the fourth. So as we begin our derivative here, f prime, we would look at the derivative of the outer function, the u to the fourth. And right now, if you feel you want to write out that extra detail, derivative of u to the fourth times derivative of tangent x, please do that. Please do that. I'm leaving it out now, but if you want to write it out still, please write it out. My philosophy when it comes to mathematics is when in doubt, write it out. When in doubt, write it out. The more detail you write out, the more it's going to connect and form in your mind. So later on, you can start leaving stuff out. So here we do the derivative of u to the fourth. Our power rule, that would be 4u to the third. And then derivative of tangent. Derivative of tangent is secant squared x. It's one of those you have to remember. We derived that in the previous section when we were using the quotient rule. And then we just need to clean it up. So we have 4u to the third, secant squared x. So u is equal to tangent x. So we put that in, and we would get 4 tangent to the third x times secant squared. Okay, and that would be the derivative of tangent to the fourth. 4 tangent to the third times secant squared.